Okay, so yeah, hello again. It's been a while since my last video walkthrough. So yeah, so as not to get rusty, so yeah, I decided to continue and post another walkthrough. Of course, to help others as well, those aspiring SOC analysts. In the same time, it's really good to share your knowledge because the moment you share something or you endeavor to share your knowledge, you are the one who at the same time you benefit as a teacher because you get to sharpen or hone your skills so as not to get rusty, right? And with that out of the way, so let's begin. We'll tackle another, yeah, one of my favorite network forensics. For this one, it's called WebStrike Lab. WebStrike Lab, again, from one of my favorite training platforms, CyberDefenders.org. So here is our challenge. So the good thing here is they introduce here now a virtual machine where you can do the actual investigation. As you can see here, and again, not to buy us not to violate any rules. We are creating a guide for just retired the retired challenges. Okay, so let's start. Okay, is this a timer? Oh yeah, so we have 30 minutes left. All right, so for this one, let's start with the first question. Okay, number one, identify the geographical origin of the attack, facilitates the implementation of geo-blocking measure and the analysis of trend from which the city that the attack originate. Okay, so there's a note here. So let's try now to. Okay, so start here. Artifacts. So we have here our WebStrike PCAP, and here is our Wireshark. Okay, sweet. Okay, so what we can do here is open our PCAP file. So the best thing here with Cyber Defenders, you don't have to set up your own VM to do the analysis. They provide the VM for you. You just need a browser, a stable internet connection, and a decent investigation laptop or a desktop that can load this. Okay, I'm opening the pickup now. So it is. So again, we're looking for the geographical origin. From which city did the attack originate? Okay, so let's find out. So when dealing with pickup, of course, what one thing we could do is we could show the statistics. Endpoints. Let's see the endpoints. So here are our IPs. Okay, we have two IPv4s. So most likely, one of them is the attacker IP. So again, since there's no internet, we could use virus total here. I do not know yet if we could do a copy paste from the Cyber Defenders VM. So we could actually right click. Oh, okay, let's just manually copy 24, 49, 63, 49, 63, 79. Let's see the reputation of this IP. Okay, okay. One thing as a SOC analyst, not everything that you see on virus total, do not take them at face value. Doesn't matter if it's all clean. Do not trust it at face value. You have to dig deeper. So for this one, it's from the US. City is Hagerstown. Okay, let's see if that's the one we are looking for. Hagerstown. Submit. Okay, it's not. So perhaps this is the other IP. 117.11. You see, I just narrowed it down. I'm not applying any other analysis yet because there's just two IP. It's just a choice between these two IPs, 117.11.88. 117.11.88.124. Okay, so this one has one hit from Shock Radar. Okay, it's from China. And what's the city here? What's the location? Can we do a city? Oh, there's no city here. Tianjin. Maybe Tianjin will do. Tianjin. Right. So that's the Tianjin. So that's the attacker IP here. So knowing the attacker's user agent assists in creating robust filtering rules. Okay, so now we can filter from that attacker IP to check what's the user agent that was used. Okay, let's go back. We can use this as filter. Right click, apply as filter, selected. And as you can see here in the background, it filtered our pickup file. Actually from here, we could inspect the packet where this is the source IP. So we could actually see the user agent when we expand the frame. Okay, let's see if we can see here. It's just somewhere here. But of course, there's an easier option. We could use the other tools as well. Okay, actually, there's a search here in Wireshark. You could use find, and you could use string agent. Oh, okay. All right. Let's see here. Oh yes, of course. Yeah, my bad. Of course, we have to check HTTP. The HTTP protocols. All right. As you can see here, now we're getting somewhere. What's the user agent here? So here. Yeah, my bad. We should have filtered with the HTTP. Yeah, to determine the user agent. So here is our user agent. Can we copy this? Yeah, we can right click, copy value. Okay, submit. There you go. Okay, so maybe as an additional context, so user agent, as you can see here, it's not really understandable by normal human language. So to gain more context for that, user agent actually resolves to we can actually look it up to know if it's a normal browser or maybe a pen testing browser or maybe something that the hackers normally use. So we could use user agent look up. So we could use something like this, and we could paste here the user agent and search. And as you can see here, it will give us more context. I mean, in layman's term, what is the operating system behind that, what device, and what OS type maker. So as we can see here, this user agent resolves two below system information. It's actually a Linux desktop, 64-bit, and it's using a Firefox. Okay, so now it's more. I think it's more. It gives us more context rather than just very nerdy nerdy string. Okay, so going back before we go to the rabbit hole. Next step, we need to determine if any vulnerabilities were exploited. What is the name of the malicious web shell that was successfully uploaded? Okay, so for this one, we could probably use another tool that could help us. So Network Miner is a very good tool for that. Let's try to load a pickup. So just open it, open that tool, and then load the pickup file. Desktop, start here. Yeah, so this one is easier to digest than using Wireshark. So we can see here there's already tabs categorizes the entities found on that pickup. So going back to our challenge, so any vulnerabilities being exploited. So this is our attacker IP, right? So let's try to find uh, images, messages. Let's see if we can find something here. Keywords. Oh, no keywords. Parameters. Maybe CVE. Nothing. Sessions. Credentials. Okay, nothing seems to stand out, but maybe we could go back to the pickup. And what we can do here is maybe we could follow the HTTP stream. Let's see what it's trying to do. Okay, Shaproma. Okay, it's downloaded the product one. Downloaded the product one.jpg. Okay, maybe we could do some hints here. HTTP post. Okay, HTTP post. Okay, let's try that. HTTP post. Oh, it's not allowing to copy. Oh, no, never mind. HTTP.request method. We can type it out. Okay, post. Okay, yeah, I missed the other equals there. All right, nice. So now we're going to somewhere. Okay. So as you can see here, it uploaded upload.php. So normally use web shell PHP. Uh, Actually, the interesting here, there's a encoded URL here, coded URL request. So the full request. All right. So now we're talking. So it's trying to attack here the ATC password. So let's read the full. Okay, where's the full URI request? Review. Can we see the full URI? Response and frame. Oh yeah, then we can follow the HTTP stream. Okay, nice. So as you can see here, it's running some commands, and yeah, it's opening a netcat connection to this IP. Okay, that's interesting. Malicious web shell. Okay, what's the malicious web shell? So it's asking us for the file name. So it's a .php file. So what have we found here? It's upload.php. right? Upload that PHP. Okay, it's this a double extension. Okay, let's go back. Mm, HTTP dot request method. Okay, let's replay that. Yeah, reviews upload.php. So, what is the name of the malicious web shell? That's it, right? Let's show the uploaded file name. Okay, we need to really follow the HTTP stream. Follow HTTP stream. Okay. Mhm. Image.php. Yeah, seems like it's just image.php. Image.php. Okay. The two outcomes. Ah, okay. So this one, it's another upload file. Image.jpg.php. Image.jpg. Image.jpg. Okay, there you go. Right. Yeah, so what I did here is I just moved to the other stream. And as you can see here, this is the first uploaded file, image.php. And then the next one, it changed to this one. And it's okay, the response is okay. Same with the first one, but it's looking for the one with masquerading as JPEG, but actually a PHP file. Alright, that does it. How many minutes more? 40 minutes. Okay, let's do this. Identify the directory uploaded files are stored is crucial for locating vulnerable page or moving. Which directory is used by the website to store the uploaded files? Okay, so where is it to store the uploaded files? So it's either of these directories slash tmp slash f. Yeah, seems like it's just slash tmp slash f. Slash tmp slash f. Website to store the uploaded files. Okay, why is it wrong? That's it, right? Are there any paths? Okay, seems there's none. But yeah, maybe we could do some hints. Ah, okay, okay, okay. Okay, so we'll the HTTP that URI contains. URI HTTP request that URI. As you can see, Wireshark it's really not scary or intimidating to use. It's very easy, and as long as you know how to craft the right query. Okay, what's the file again? So the file here is image.jpg.php. Image.jpg.php. Right, gotcha. Alright, this is it. Okay, HTTP URI. So we could follow this one. Follow HTTP stream. HTTP URI. Review uploads. Slash review slash uploads. Slash review slash uploads. Okay, it's not right. http.uri to upload the directory. Okay, let's see the http. Yeah, it's definitely review.uploads. So why is it? Hmm. Maybe our format was wrong. Review slash uploads. Ha ha ha. Reviews. Oh, okay. Reviews slash uploads. Yeah, missing S here. Okay. See, attention to detail is critical here. Yeah, missing the S. Alright. Okay, we still have 10 minutes for the lab, but no worries, we could relaunch it anytime. Which port opened the attacker's machine was targeted by the malicious web shell for establishing. Okay. Yeah, I think it's the netcat that we saw earlier. But yeah, let's do the hints. Yeah, okay, okay. So let's go back to that query, the post. Yeah, the stream 4, the one we found earlier. So let's HTTP stream. So this one, as you can see here, it opened a netcat connection, reverse shell, to its C2 via this IP, followed by the port. So the port is 8080. So if I'm not wrong, should be 8080. There you go. And for the last question, recognizing the significance of compromised data helps prioritize incident response action. So which file was the attacker attempting to exfiltrate? Okay, which file? Oh yeah, this one we saw earlier. Remember? Uh, it's trying to do. Yeah, we've seen this earlier. Uh, let me show you. Let's filter the IP again. IP. This one. IP dot. Let's filter the attacker IP. Okay, so starting with this one, we could follow the HTTP stream. Oh, let's go to the HTTP. Right. Actually, we've find it earlier. Let's go to the next stream. Yeah, this one. Open the connection. This is the uploading of the web shell. Okay, this is the one as well. Uploading the web shell as well. Again, going back to the question. Which file was the attacker? Yeah, it's it's just in here. Admin uploads, get uploads. Yeah, I found it. I know the answer already, but I want to show you where in the pickup file it is. Uh, okay, as you can see here, this one you already have established a connection, a burst connection. So he did a reconnaissance command. Who am I? Then he did a uname dash a. The attacker did a uname dash a to find out the OS and version, and then pwd for the present working directory. He lists the contents of the home, and then eventually he's really aiming for this file etc dash pash wd, right? And then as you can see here, he copied the contents of it and sent it back to the C2. So now we have the answer. It's He actually copied the contents of the passwd, which contains the list of the users, right? The list of the Linux users. So that's our answer here. All right, congratulations, guys. I hope you learn a lot as I figured out this lab. Yeah, it took some time. It's been a while since since I post a challenge walkthrough. But yeah, I hope you enjoyed that. Thank you very much, and on to the next challenge.